Okay, I'm just going to step through the interface. I'm going to have to assume that you have brought yourself up to speed on what a tesseract is and some of the different rotations, and you've seen some videos and maybe worked on a little code yourself, and so you're going to be able to appreciate what I've done here in terms of a manual interface for selective rotation of the around the different planes of rotation. And I say plane advisedly. In 4 dimensions, when you're rotating around a volume. You're rotating through a volume around a plane. In 3 dimensions, you're rotating around an axis. You're rotating through a plane and around an axis. But when you're rotating in 4 dimensions, you're rotating through a volume around a plane. And I'm not going to try to make more sense of that, except simply to demonstrate what we've got going here. So we're going to zero out the rotations on the different planes, and we'll just step through them. So that's 180 degrees. 180 degrees on the Y. 180 degrees on the Z axis, so it's pointing 90 degrees from the computer screen. Now I'm going to tilt it a little bit so that you can see as we invoke the 4th perpendicular. This is where you get the classic tesseract folding into and out of itself through higher space effect. And what you're seeing, one plane is fixed for illustration purposes, and the interface allows you to shift that plane around. Going to zero out everything again, give it a slight tilt so that you can see the apparent dimensionality of it in 3 dimensions, and I'll just show how you can rotate that selected plane that you want to highlight around the cube. So as you rotate, you have one fixed frame of reference that isn't completely confused by the wire frame. So anyway, if you're interested in a little bit of graph theory and you like to keep track of the segments and their invariant relationship through one vertex, this allows you to do that. And again, you can step through the sequence, and again you can do the same manual rotations. And that's only giving you 3 segments. You want to know how that segment, those segments, which ones are in 4 space. So if I start to try to explain this, it gets real complicated. Now the cube per se highlighting is incomplete. So I'm just showing that for entertainment purposes right now. The polygon filling routine needs a certain kind of sequence among the vertices, which I have not written into the data arrays. I need to do that. But in the meantime, you can watch this. If you had the program, you could kind of play with trying to understand visually what's going on through these rotations. But anyway, that's what you see is what you get. for now.